Hello, my name is Isabella and I will be your host for another mathematics video brought to you by RJ. Today I have a very exciting question for you. Are there infinitely many twin primes? The Twin Prime Conjecture states that there are, but it has yet to be proven. Let's see if we can solve it today. We will do so by reframing the question, but before we do so, let's go over some facts about primes and twin primes. A prime number has been defined in several previous videos. To reiterate, a prime number is a natural number that is only divisible by 1 and itself, up to associates. Furthermore, it has only two divisors, up to associates. It can also be defined by a natural number greater than 1 that is not the product of two smaller natural numbers. It has been proven by Euler that there are infinitely many primes. This is a set of prime numbers. Twin primes, on the other hand, are a set of two primes that have a difference of 2. Let us denote the set of twin primes are blackboard P sub 2. Our goal is to determine whether or not there are infinitely many subsets in this set. As we can see, this set is filled with subsets of two numbers. Is there a way to replace each subset with a single number? What does each subset have in common? We will now introduce a new concept called composite sandwich numbers. Each subset is a pair of twin primes, which means they have a single composite number sandwiched between them. Therefore, we can now replace this set with this set, the set of composite sandwich numbers, which we denote as blackboard S. Since each of these numbers corresponds to a unique subset of the set of twin primes, now all we have to do is determine whether or not the set of composite sandwich numbers is infinite. How do we do that? By definition, a composite number is the product of primes. So, if C is a composite sandwich number, then it is a product of primes, which can be expressed as P sub 1 through P sub r. Now, let's choose the subset in which the set of twin primes that correlates with C. We can obtain the first twin prime in the subset by subtracting 1 when we denote n sub minus. We can obtain the second twin prime in the subset by adding 1, which we denote n sub plus. Obviously, both n sub minus and n sub plus are prime, which can only be represented by a single prime number. Then we obtain these equations, and they are in fact equal since both are equal to C. But what do we know about both n sub minus plus 1 and n sub plus minus 1? They are both composite. We get exactly what we have here, a product of primes. For the sake of reframing the twin prime conjecture, I replace C with KQ. Why? I want to factor out a specific prime Q. Now, it's time to reframe the question. Does there exist a positive natural number k such that both n sub minus and n sub plus are prime for all prime q? Why is this reframing helpful? We know that both n sub minus and n sub plus is a set of twin primes. We also know that there are infinitely many primes. If we can find a positive natural number k such that both n sub minus and n sub plus are primes for each prime, then we can match up each prime with a set of twin primes. Hence, there are infinitely many twin primes. Of course, when q equals 2, kq minus 1 does not hold true since 1 is not prime. So, we must eliminate the case when q equals 2 in the reframing. But this is not an issue since infinity minus 1 is still infinity. Now that we have reframed the question, it is quite simple to solve. Say P sub r and set it equal to q, which can represent any prime number. Now we have both q's on both sides. Hence, we can cancel them out. Now we have a solution for k, which is the product of the remaining primes, which is a positive natural number. Thus, there does exist a positive natural number k such that both n sub minus and n sub plus are prime for all prime q, except 2. We can therefore conclude that there are infinitely many composite sandwich numbers, which implies there are infinitely many twin primes. The twin prime conjecture is true. I hope you enjoyed the video. If you did and would like to see future videos, please like and subscribe. Also, leave a comment telling RJ which areas of math you find interesting. Thank you for watching.